All right, so like I said, we did stacks and queues last time as linked list, and we were just doing the stack version as an array, or the array version of the stack, I mean. And then we have the queue version to do still, okay? We're still doing smaller tiers. Yes, so next class, I was going to bring that up. But yes, I'll have a smaller tier next class that will be half of this one. So it's not 1,000, but it's like 1,500 points or something. So yeah, it'll be half of that. Whatever, 1620 will be the value of that, which is the equivalent of 50 points. I just don't want to put that up today because I don't want to have a billion different submissions. So yeah, I'll do that next time. Okay. So as you can see, it's a pretty small piece of code. We went ahead and did the push and pop. The only thing that we haven't done is the resize. And also we did do the function call for resize, we did. So yeah, all we gotta do right now to finish the stack is just do the resize function. And of course we have to do that because it's an array, and we hard-coded that to start with a size of 3, small enough that we can actually see this resize without inserting a billion things. And so we gotta make a decision of when to resize. How big do we want to make it? You know, double the size or add 3 more to it. We gotta make that decision. And then after that, we can go ahead and implement this by just making a brand new array, copying over the current array, deallocating the other one to avoid memory leaks, and then you're good to go, right? And like I said, I guess if we finish the circular queue early, we can go back here and do like a copy constructor, because I mean, technically speaking, because the array is dynamic, bad things can happen if you don't follow the rule of 3, which is that whenever you have a dynamic allocation and you have some sort of constructor with dynamic allocation, which means you probably have a destructor that deallocates that dynamic memory. If you have the destructor, then you should probably also have a copy constructor and overload the assignment operator so that it also doesn't break it. Otherwise, you have a shallow copy, which can do bad things. You can get some crashes and other bad things you don't want to happen. So let's go ahead and just do the resize function. So for resizing, what I'm going to just go ahead and do is I'm just going to make it double the size. Actually, yeah, I'll do double the size. Yeah. So by double, I mean maybe we'll just increase it 3 times more. Because normally I would just double the size, like literally multiply times 2. But I want to be able to call the resize function maybe like 2 times. So yeah, let's just, I don't want to make it too big because then I have to make like all the inserts to actually have the thing get called. So yeah, we'll just add 3 to it. Okay. So what I want to do is so I know the function gets called whenever the time comes to resize. So all I really got to do is make a brand new array. So I'm going to call this new array, and then go ahead and allocate the, what is the name of this class? It's just T star. So it's a new pointer, make a new array. And then in this case for the array, it has a parameter, or what is it? No, it doesn't have, it has no parameters. Okay, perfect. So yeah, okay. Yeah, okay. So I can just make a new T make it double the size. So I'm gonna go ahead and get the current size, which I think I have in the variable called size. No, I have capacity. And I'm gonna take capacity and I'm gonna add 3 to that. So I'm making the array, whatever the size is, plus 3 extra new spots. Again, you probably want to at least multiply times 2 this, or do a bigger increment than 3. We're keeping it small scale so that we can actually test to see if this works, and that's it. So now that I made the new array, I want to copy over everything from the old array to the new one. I want to make this a deep copy, so what you definitely do not want to do is make this. You don't want to do this. That is going to make a shallow copy because you're just copying pointers and bad things will happen. So I'm going to make a for loop. I wish I could do an auto for loop, but not. It's a normal for loop. it's going to loop the capacity amount. So I is less than capacity, I plus plus. And when it comes to copying an array, a stack, it's nice. All you do is just literally copy everything in the same spot, and you're pretty much done. For the queue, that's where you gotta like dequeue and enqueue everything. So we'll look at that when we get there. But yeah, for now, this is literally as easy as just saying the array I. It's gonna get the old array I, which I believe is just called array I. Yeah. When you do that, you don't need to update top, because top is still gonna be pointing to the next available spot, which now is actually a valid thing in the array. So yeah, I think that's all you gotta do. They should all be valid after that, so we should be okay. So yeah, I feel like I should do something. Oh, one more thing actually. We want to update the value of capacity, right? Because right now capacity has the old capacity. So we want to update new capacity. Yes, that's the other thing I'll do. So capacity gets capacity plus 3, right? Because that's what we're updating it to. So yeah, that way it knows that it's a bigger array now. And then as long as you do that, then this will automatically go. So what I'm going to do though is I'm going to add one more thing in here though. I'm going to do a cout statement so that we can actually see that happen. Okay, so now I have the same code as before. Please run. It's just problems though. Int I is equal to 0, I is less than capacity. Semicolon. Semicolon again. Okay, so I think it's running now. And so now it's doing the same thing, but let's insert one more thing, because now that's going to trigger the resizing. So there you go. We don't see anything before that because we don't print anything, but it's saying resizing array from 3 to 6. So if I go in and insert, a couple of more D's in there, if I do 6, it shouldn't resize. Yeah, resize once, but it shouldn't resize twice. But if I add one more letter in there, one more D, then it'll resize twice, as you can see there. And then let's put the couting in a. What do we have as a check when we try to pop from an empty one? We don't have anything. Okay, so then let's put a for loop and just control how many times it runs. And I is equal to 0, I is less than. I guess we have 7 things. I plus plus. And just call that. So there we go. So it's pop, 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 CBA, pop. Yeah, so we popped everything out, okay? So as you can see, the resizing is working fine now. And however, if at some point it became size of 9 and then it goes back to just having 2 or 3 items, we're not shrinking it. If that's something that you want to do, which I'm not familiar with that being very popular, then that was something you would do in the pop. So you might say, like, before you return this, you might say, like, if the top is like a quarter of the current size of the array, then maybe we want to shrink the array to half the size, something like that. So that would be basically the same thing as the resize. Just beware that if you're shrinking something, you got to make sure that that you don't shrink it too much, right? Other than that, one thing I did forget to do here is to deallocate the old array. In fact, this is really bad. Not only did I forget to deallocate the old array, but we're still using the original array. This is going out of bounds now that I look at it. Let's see that all happen. So that's terrifying, actually. So Valgram will tell us about all those nastiness things. Well, it says memory leak, but I was expecting error. Oh yeah, here we go. 11 errors. You see them, right? So these errors are because we are actually not. We're not using the resize array. We're still using the same array because I forgot to do a big thing here, and that is I want to update. Now that I finished doing creating my new array, I want to do two things. I want to deallocate the old array. So delete array. There we go. Deallocate old array. And then this is a shallow copy right here. It's just changed pointers. So have air pointer point to the new array. There we go. So now we're actually using the array that we just created and not just like, you know, smashing the stack. So there we go. No memory leaks, no errors. Okay, so yeah. Like I said, I'm not really gonna do the resizing small. Maybe you have time, but it's not very popular. But again, all you would do is before this line of code runs, you want to compare the capacity to the top, and you know, if it's too small and you're really skimping on space, then you can do that. Okay, moving on. We can go ahead and do the array version of a queue, which is, we're going to do the optimized version, which is a circular array. That is going to include a enqueue function, a dequeue function, and a resize function as well, because even though it's a circular queue, so we can maximize the space in the existing array, we may hit a situation where we just need a bigger array, so we want to be able to resize it. And it'll look very similar to this, actually, but you know, let's go ahead and do that. So let's, I'm debating if I should, let's do it in a new file, just because it'll be cleaner that way. So this is going to be 23, the stack, and I will be updating this again today. I did update it last time. So I'm just writing up here that you can't see it, but stack. Using array implementation. 1124. Well, technically, you did it in 2 days. Okay, and then I'm going to make a new one. This is going to be 24, and that's when I'm going to store the one I'm just about to do. That'll be the last one. So look at that. Just for memory's sake, nostalgia. This is the first code that you did, or that we did in class. Look, it's like a little simple for loop, and then from there, code 4. Look at that. We were doing that Tamagotchi stuff. We're making classes, and then we did inheritance. And then look at us, doing all these amazing data structures, linked list and stacks and queues. So, well done everybody that's still here. So, yes, I'm very proud of y'all. All right, so let's go ahead and make a queue then. I mean, don't celebrate yet. You gotta pass the final, so just make sure you don't trip at the end of the road. But yeah, it should be okay if you got this far. So I'm gonna make my life easy by remaining every. Oh, you know what? I should just find and replace. Wait, no, I'm not doing that right. Here we go. Okay. So you'll definitely look back with nostalgia when you finish it with 302. Then you'll be like, dang, I miss the days when like all we had to do was make like a bucket, you know, class bucket or something with like just class variables or something. And you'll be like, ah, those were the good times. It's like now you look back at 135 and how trivial that stuff is. Like, oh, for loop, you know, before you were like, oh my gosh, what is this thing called struct? And now you'll be doing like virtual functions and virtual classes and things like that. So yeah, it's all about perspective. It's like struggling in school with fractions, and now you're like, fractions, huh? I wish we were doing fractions. Okay, so you know, things will change. This will not be just like a copy paste easy thing, but I thought of just kind of putting in you know, starting out with the same code as before and then just kind of going from there. Uh, 218 is it's a lot of work, but it's not like hard. It's just a lot of work. Okay, so we have our testing where we're gonna be able to enqueue and dequeue and all of that. Oh, you know what we never really did and we could have done too? A print function. That's okay, we'll do a print function for this one and then we can copy and paste it into the other code if we want to, because that's just printing an array. It's just a little for loop I printed on the array. It's like, there's no high science there. Okay, so for the queue, we're gonna do the same thing, except we're not gonna call this top. We're gonna call it front, I think. I think that's a good replacement for that. It's the same changes that we did when we did the stack in the queue. Just naming conventions wise, we're gonna use front for that. Front is gonna point to the next. Oh well. Actually, this should be more like back, not front, because it's going to be the spot where we insert things to. So let's make front back. Actually, it'll make more sense that way. So the back of the line is where you put things in, right? Where you enqueue things. So we want that to kind of be the size of it, and then the front is the next thing you serve. So that one we start out with 0. So okay, so for initially though, we'll make front and back both be 0. Actually, technically, let's make front be -1. Or no, we'll make it 0. We'll make it 0. Both could work, but it's just depending on your preferences and how you handle the indexing. If you want to have the back point to the next available spot or to the current last thing in the back or things like that. Okay, so for our constructor for the queue, we just want to initialize these two variables that we have, which are front and back. So let's make sure we actually create those variables. I probably will want to make them private, but I'll make them public for now. We want to set the null to 0, and then we want to still have an array, and we're still just going to make it size of 3 so that we can resize it. And then we want to allocate the memory for that. We want to deallocate the memory there. We want to have a capacity variable so we can know how big the array currently is. And then we just want to make it enqueue and dequeue function. So enqueue and dequeue. So that's a good prototype for the class. I guess I'll add one more function, which is the one that I was thinking about, which is just a print function. So just a simple print. That'll come in useful to see the structure of this thing. And then, yeah, so now let's go ahead and actually create our functions. So for now, I'm going to leave the current resize function that we have because I want you to see that it doesn't work and the problems that it causes, which are, again, you can't do that. You have to dequeue and requeue, so we will have to modify this loop. But I'll leave it as it is for now, so you can see how it screws it up. And then, or will it screw it up? I guess. Yeah, it probably will. Yeah, I think it will screw it up, but we'll see. Maybe it'll be okay. I recall it screwing it up, but yeah, it's been a while. We're obviously not going to call that push and pop. We're calling it queue and dequeue. So now we got to modify enqueue and dequeue. So let's start out with enqueue. So with enqueue is the same thing. So in fact, just so we remember, it's a circular array, but I'm just going to make it flat. So if you got some numbers already in here, and you want to add something in, we're saying that we have back pointing to the next available spot because we started out with 0, which is empty, right? So it's always going to point to the next available spot. So all we got to do at that point is basically just like a stack. So throw in the number and then increase it by 1. Obviously, when we get to a situation where like this next available spot is outside of bounds, we want to check if it's out of bounds first. If it is, resize it and then try to insert it. So that's for the back. For the DQ operation, I'm going to have front point to the next available item to DQ. So that way we just take it out and then just increase this by 1. So that one's going to be pretty easy. To achieve the circular array part though, we need to do modulus to these things. So we'll do that later. Let's just do the basic version first. Okay, so we got back, which used to be top for the stack. So I think this will work the same way it is currently set to. If back is greater than or equal to capacity, resize. Otherwise, insert in the back the data and then increase it. So yep, this is all going to work the same way that we have it. However, the modification we're going to have to do is for the modulus operation. But we'll come back to that. Let's look at the DQ. The DQ, oh, this one shouldn't say back in this case. In this case, it's front. So front plus plus, right? Because we want to move the front pointer there by 1, and then remove the item first and then increase it. That's why we're using plus plus, because what this returns is if front has a value of 5, this will return array 5, and after it returns that number, then it's going to increase front by 1. Okay, just make sure you remember your post and pre-end command. Otherwise, you're still in C135 world. So yeah. So again, this is also good to go as is now. So they're both perfect now. The only thing we got to change is this thing from back to front. However, we still got to make it into a circular queue, right? So for that, what do? Well, we don't always have to resize. Like right now, we're just resizing when we go out of bounds. But technically, the circular queue says don't resize, just wrap around. And only when these two things are pointing together do you want to resize. So we're going to use modulus for that. So we know the capacity is currently the size of this. So in this case, it would be 6. So this is index 0, 1, 2, 3, 4, 5. So we want to say when back is equal to capacity, then we want to either resize if the thing is like actually full, or better yet, just do modulus so that it wraps around. Well, you don't have to use modulus. You could just set b to 0 here, and that would work. So this would work as is here. The alternative and cooler way with modulus is just to say b plus 1 mod capacity. That will do the same thing. Actually, plus 1. But if that, no, I don't like. I'm trying to see how I can make this one line of code. The thing with the modulus and doing the plus 1 is that here. I don't know if this will work, but I don't know if this will compile, but you could do something like that. I don't know if that's legal. I don't think that's legal. I think it's going to yell at me if I do that. So if it does yell at me, then that's okay. Because then you can just do b++ afterwards. I feel like that'll yell at me because bmod capacity is not like not a variable. And I think that the post increment requires it to be a variable. So yeah, that'll work though. And like b could have like 1,000 in it, but the modulus will take care of knowing where it's supposed to go. So yeah, either or. If this bothers you as like complicated, then you could just use this method. Both of them will do the same thing. What you want to do is basically when you go out of bounds, you want to reset b to be the beginning. So let's do it both ways. Let's do it both ways and test it to make sure that both work. So instead of resizing here, we'll worry about how to check for resize later. So let's comment this out. And say back mod capacity. Back mod capacity. And then that would be good to go like that. That's one way to do that. Alternatively, I can say if back is equal to capacity, we'll do it in one line too. Back gets 0. Okay, so either of them. I mean, you can put both. it's pointless. So I'm gonna do the modular's one because that's cooler. Nah, I'm gonna do the if statement because it's more classic and easy to think about. Same thing for the front. You actually want to do that too. Although now we can't make this a single one-liner because this will we gotta split it. Or actually, no. We can still leave it as a one-liner because we can say if front is equal to capacity. Well, that should never happen. Oh, yeah, no. We definitely want to split this up. So we're going to make it a temporary variable that returns what we want, which is front. Well, actually, what we got to think about, we want front is pointing to the front, right? So we want that back. So, and then we want to increase front if we want to have it the same code as we had before. And then here we can just say return temp, right? So now we have the same code as we had before, but now it's easier to modify because we're not doing it all in one line. So when we do front plus plus, we want to make sure that this is not pointing out of bounds. So we want to say either front gets front mod capacity. That will wrap it around if needed be. Or we can do the modulus. So we can say, or sorry, we can do the if statement. So if front is equal to capacity, then front gets 0. The same thing. So both of these again do the same thing. And I'm going to be, you know me, I like to play it safe. I'm going to make these greater than or equal to, just in case some weird thing happens. But again, it shouldn't have to. In fact, if something weird happens, I should probably fix it rather than patching it. But that's the real world life. You just patch things. Yeah, so again, either of these will work. So I'll comment out this one and run the if statement version, but we'll flip it afterwards. Okay, so I think we got the circular queue running. We don't have the resize running yet, but we'll leave this resize version. So you can, so let's see if it just works. I think it'll, I don't know. See, I'm thinking if it'll work. I know that's like I've tried it in the past and it didn't work, but I don't remember why it wouldn't. To me, it makes sense like it would just work. So who knows? Let's just discover the same thing I probably discovered the last few times that I did this when I talked to it too. So yeah, so we'll leave everything as it's now. Well, here let's. Oh yeah, we got to do the print function this time because I actually want to see, because that'll tell us more if the thing broke too. Also, I would like to use different letters because it'll be easier to see if things break. Okay, so the print function is just, I'm going to make it something nice and simple. I'm going to say cout q, and then I'm going to run it through a for loop. I is less than capacity. Actually, the one capacity, that's going to print out all the valid spots, but also the invalid spots. Sure, why not? Let's print out two versions of this. One with invalid data and one with valid data. We'll do that. That'll be interesting to see. we'll just do something like RI, and then make sure it's split with a space between them. I think a space or a line. What will look? Let's do a line and the space. Yeah. Okay. So that'll be. We'll print it out twice. We'll print it out like that, and then we'll also print out only the valid data. So we can see the garbage in it that's being ignored, or hopefully ignored. So in this version, instead of going to capacity, what I want to do is I want to start out where the front is. So whatever index the front currently has, I want to print that. And then all the way to back minus, well, I can just say back and say I is less than back. And then it won't print that out. So that will actually print things out nicely. So we can actually even say F and then print all of these out. And afterwards say like cout B for back with space. No, we don't need a space. And then let's add a line feed here. And let's also add a line feed here. Oh, here, I can just put it in here. What's a better name than Q? Valid Q, whole Q. Okay, so for now, let's just run it until this line and then print it. Also, this is just a personal thing. I want to rename this from S1 to Q1 because it's the Q, not a stack, and that just throws me off. Okay. Let's baby steps. So let's just end the function after just putting 3 things in and then inserting it. In fact, let's insert 2 things first. Run it. Okay, hold on, I gotta fix the errors before it lets me compile. Comma there. Semicolon here. Semicolon, semicolon. There we go. So we can see the whole queue has A and B, which we put in the queue, and then it has nothing. I like the fact that it printed nothing, because it could have printed out garbage, but it just printed nothing, so that works. And then the clean version of that, the clean version printed some weird stuff for the valid. That's trippy. What happened there? Valid queue. Let's write the word front to make it easier to see then. Front and then back. Oh, I see. It's not trippy. It's the word back. So I'm confused by my own syntax here. There we go. Front, back. Yeah, so that's where that B came from. It's just the word back. So you can see this is the whole queue. So all valid and invalid data. But you can see that this is actually stored correctly. We got front, A, B, and back. Okay, that works. Let's throw in a C and see what happens. Same thing, no resizing. Now let's try and actually throw in multiple things. Well, we can leave the print statement for that one. But I do want to add in the print statement once we insert everything in there. And let's not test the DQ yet. So let's just return 0 here. So, yeah, things broke. Things definitely broke. Oh, wait. Oh, I haven't actually, I forgot to comment out the resize. So I haven't done the resizing yet. Okay, so how do we do the resize? So we can no longer just say that when it goes out of bounds, we resize because we are doing the wraparound. So what we need to do is, again, how do we know that this is really full? Because at this point, if we want to insert something, this just goes over here, right? And then you just insert something there. So the only way you know it's full is when both B and F are pointing to the same spot. That means that either it's full or it's empty. And you will be checking that in the NQ function. So that means it's always going to be full. It will be only in the DQ where you would actually find out that it's empty. So we can do that with the if statement here. We can say if front is equal to back, or actually let's leave it as we had it before. If back is greater than or equal to front, then and technically speaking, they just have to be equal, but again, you know, I like to play it safe. So I'm saying if the back is literally greater than the front, that means that like this wrapped around Oh wait, no, I can't do greater than. I have to use equals. So here I have to play it risky because if I do greater than, it's still actually okay. So yeah, I should make it equals. So yeah, I'm saying if this goes here and touches here, then that means that we are about to overlap. So if back is equal to front, then that's when we want to call resize. Aha! This is why it breaks. Now I remember when I see this. Because here's what's going to happen when you resize. Alright? This is why it breaks. Told you we find out why the simple copy for loop doesn't work. Because what happens if we do this? Like, you know, we have this empty. We're inserting something. So right now it's pointing here. Goes around. You insert like some value. Let's put a 7 in. This goes higher, but it still doesn't finish. Next time we try to enqueue something, it's like, oh, well, these are equal, so I need to resize. So you go on your resize. So let's make a bigger one. Okay, that failed. There we go. So let's just make one that's like 2 bigger or something. So we have 2, 4, 6. We have 2, 4, 6, 7. So let's have one more spot. So if you just do the for loop copy like with the stack, then you would just literally copy it over. So you have 7, 2, 3, 4, 5, 6, right? So you have more space now. But here's the issue. You still have your front there, and you still have your back there. So now, not only do you still don't have a space to insert because you're still trying to insert over something that exists. But you have like random spots in your list. So if you look at this from the circular perspective, people in your line, you resize the line by like adding a random spot in the middle of the line that's just empty. So like you achieve nothing. So what you have to do is you have to say, okay, we made a new line, and now I have to dequeue things and put them on the new line at the front. So like dequeue this, put it here. Move your front over by 1. Dequeue this, put it into the new line by enqueuing. Dequeue, ignore the little, yeah, that. Then dequeue, so you have to dequeue things one by one and enqueue here. Wraps around, dequeue that, and then it goes back to here being the same, and then you're good. And so here in your new one, when you're enqueuing, your front is going to point there, and your back is going to point to the next available spot. So now you can actually take advantage and use the empty spots. So that's why you can't just do a for loop that just copies things over. Yeah, there we go. I knew we'd find out. Wait a year from now, and I'll probably be in the same situation. Be like, oh, now I remember that I used to remember too. So yeah, so what that means for this is that this for loop does not work. So instead, what I'm going to actually, well, I can leave the for loop actually, but I can't just do this this assignment. What I'm going to do is I'm going to take advantage of my functions that I already have, and I'm just going to dequeue and enqueue the number of times that I have for the capacity for the old one because I know it's full. So I'm going to literally write self. Well, you need to write the word self. You can just say enqueue, or no. Okay, so, okay. There's a couple of ways that I can do this. One of them is that I can create a new queue, like a temporary queue, and then just use that. I can also manually increase things because I know that in the new list, things are going to be inserted in like a nice order from beginning to end. So I'll do that one because it's the simplest version actually. But I'll tell you that you can do the other ones in this, like I'll explain how those would work. So instead of saying RI here, I'm just going to call the dequeue function. Like that. So every time this runs, I'm inserting something into the new one, and it's whatever I dequeue. And I know that because front of the line gets dequeued first, and that's going to get inserted first. So that's good. That's all I got to do. So I got to just change. That was nice because all I had to change was literally here. Like I changed that from ARI to just dequeue. That's the cleanest version that I can think of. Do I have to do anything else? No, that's the cleanest version. The other version that I was thinking is I can make a new queue object inside of this function and then enqueue into that object. So like, just to see what that would look like really fast, I would say like qt new queue. I don't think there's a constructor. And then I would literally say new, for the same for loop I had. So let me just copy that for loop over real fast. And then here I would say new queue dot enqueue, and then inside of that put this dequeue. And then once you finish doing that, then take the new queue and take the pointer of that, which I think is private, but you should be okay because this is a member class. This kind of goes back to that operator overloading logic. Take that array and store the, or take the old queue array, so this is just R, self R, and assign the new queue array, which is nasty. It's just this nasty stuff to do. And before you do that though, you do want to make a temporary pointer that can hold the old one. So you basically got to flip them around. So take that, copy the other one over, and then put in the new one the old one, and then just flip the capacities as well. So capacity of the one is going to get the new queue capacity. Actually, but even doing this, before you can do this, you have to make sure that you resize it. You make the resize. Yeah, see, this just gets more and more complicated because then you have to resize the array too here. So you have to like you have to do t star new array, new t capacity +3, and then delete the current one that you have, put the new one you have in there. Oh, here's. Then this is not needed. You can just use this one. Save a pointer, like save a tree. All right, so then you can run this code as I had it here. The capacities, you don't need to change them. Yeah, you don't need to change them. So yeah, there we go. So this will be the equivalent of that. I think this is good. We'll test it later. But you can see that that is just like an utter mess of code versus like one line of code change. So much better to do that than to do all this, right? And I think this will work fine. So let's just stick with this one for now. So I think this should all be all good to go now, the resizing. Let's see if it works. Let's see if it compiles. Probably some typos somewhere. Nope, no typos. Okay. Oh, I guess we never updated capacity size maybe, because I am getting whole queue, or did we not insert things? Let's see. So ABC, whole queue for print. We got GB. Okay, yeah, something went wrong. Something definitely went wrong in all of this. It broke. I think we broke it. Did we uncomment all this code? So we got the new array. We dequeue into the new one. Yeah, that's all good. Oh, I know what we gotta do. We have to reset the pointer, the front and back pointers. That's what we have to do. They're still pointing to the middle. So like, we copied the new array into the nice spot, but like they're still in this case pointing to say, since the spot was array was twice 3, it's still pointing like that. So it's still messed up. So we just gotta reset it. So to reset it, set the front to be F, and then set B to be whatever the next available spot is, which is whatever your old capacity was, basically, that value. So front gets 0, and back gets whatever capacity was before you increase it. I think that will be the next available spot, because like if capacity is 6, it means that 0 to 5 are full, and you were trying to insert the 6th one. So you want this to point to the next available spot. So I think if we do that, that will fix it. If you don't forget the semicolon, that is. Okay, let's see if this is better now. So we have ABC. Why is it resizing at this point with 3? We have 3 spots available. Does back and front start at 0? 0. It's probably because I don't know why it wants to resize in the beginning when they only have 3 items in here. Probably my first insertion is probably breaking it. Let me see how that is set up. So when I NQ, so the front and the back, it's resizing right at the beginning. That's right. So because back and front are currently set equal, it's basically resizing when the thing starts. So, why isn't it just resizing nonstop then? That's interesting. How do I fix that? So at the beginning of the entire thing, we got front and back and they're equal. So that's why it's like, oh, they're equal. I should resize. Let's do a patch. Well, this patch will not fix it fully. And that is, if front and back are equal, I was going to say front and back are equal and the size is 3, then don't resize. But what happens if the entire queue is emptied? Then they're going to be equal again. Let's make a Boolean flag to fix that. Or we can make back be always pointing to the last available spot. If we do that, then we don't run into this problem, I think. Nah, let's just do the Boolean flag. So we'll do Boolean flag saying whether the queue is empty or not. We'll make it internal. Actually, that's a good thing to know. That's public, so we'll make it as empty and we'll eventually set it to true. And then whenever we NQ something, actually, let's just instead of making a Boolean flag, I'm gonna make it a size variable. It's kind of gonna tell me how much data is currently in the queue. So every time I NQ, I'm going to increase it by 1. And every time I DQ, I'm going to decrease it by 1. Let's make that at the bottom of the function though. And then I can check here if front is equal to back and size is not equal to 0, meaning that the queue is not empty. That way it won't resize when it's empty. Okay. I don't know if this fixes it. I think it might have broken something. We'll see. At least it's not resizing in the beginning now. So we have ABC and we have the entire thing. We have ABC. And then after the resizing, or why is resizing not called now? Why is resizing not called now? We have size plus plus here, and then we have size minus minus. So those are definitely running. Front. Oh, probably because of this modulus thing should happen before. Yeah. Let's go ahead and move this code above this. That way it knows to resize if it actually is going in the beginning. Yeah. Okay, so I'll explain what happened in just a second. We have an edge case scenario that we hadn't thought about. The first time it ever fills up and wraps around. So like, for example, let's say there is a 1 and a 5 here. This is here. So it's out of bounds, right? So before it, the only way we know to resize is if the things are on top of each other. So here it's out of bounds. So the next time it runs, it's going to do the modulus and then try to insert here. And that's when it would know that it needs to resize. The check that we have first is are they both pointing the same? No, then we don't need to resize. Okay, do the modulus and then insert. But you're like, oh no, I can't insert because like I have stuff there. So what we need to do first is we need to do the modulus first. If it's out of bounds, check then if they're equal, and then decide to resize. So we had to flip that piece of code. So that was the issue with that, or at least that's what I think the issue is. Okay, so well, some things may have to be fixed here, some things may not be fixed. We'll see, because we got it working, but we have double resizing happening now. Oh, that's fine because we have a lot of things in here. Yeah, that's right. We have 9 things, or sorry, 7 things. So that's fine. So first, ABC. Front and back is all good. Then we insert one more thing, so it resizes. But then when we insert the G, it resizes again. That's why we see 2 resizings here. And then what we currently have is A, B, C, D, E, F, G, and basically 3 available spots. But the valid data is correct, which is just A through G, right? We don't have empty garbage in there. So that works. Finally, let's try the DQ and see if that's going to break it. We can see that DQ works, and so compared to the stack, when excuse me, when you push everything to the stack and then you pop it, it comes out in reverse. On the Q, it comes out in the same order you put it in. So you can see that the letters are correct in the same order and not backwards like with the stack. So it works now. The last thing that remains to check is whether or not using the other system with modulus instead of the if statement would work. So let's just switch it over. As you can see, it works the same way. So either one works. So it's a preference. Whatever you think is more readable. You can even, actually you can, but I would not put one way and one the other way, like commit to using an if statement or using modulus. Also understand that they work differently, but yeah, it's cool. Yep, easy. Definitely the circular one's the hardest one to implement. You can see this, basically there were like 80 lines of code, but they were more tricky code because we had to think about like increasing, decreasing, all these edge cases and all that. With the linked list, I mean, sure you can crash because you messed up the pointers, but like it's not as like meticulous as like checking whether you increase, move, down, up, down. So there's no pointers here, so the code itself is simpler, but the brainstorming you have to do is a little bit harder than some of the other things we've done. You know, like what do you do this check first, you increase this, what happens if it's empty. You have all these things you got to keep track of. And this is kind of how 302 goes. Some code is easy, but it takes a lot of thinking of how to actually do things and get things running and whatnot. So, like I said, we don't have this luxury in 302 where you just get to spend like a whole day or a week coding an algorithm. We just cover it. You're like, this is the logic, you go code it. And then you have to actually translate the logic into code, which is what we've done today, basically, compared to last week when we went over the logic. I said I was going to, so let me just copy over this print function. I can copy this version of the print function. So let me just throw it in here. Stack. In case you run this code, that you can actually get to see it. I'm just putting a very simple print function. Just runs through the capacity, prints everything out. Actually, instead of capacity, I'm going to run it for top here. I already forgot what we did for top. I think top the next, so we want to do top, yeah, like that, because we don't want the actual top, because that will be invalid. So yep, that will run. If not, yeah, easy fix. Actually, we'll test it in a second. And then let me just add it here. Void print. Okay, so we'll test that in a second. Let me first back up this one. So remember, test is open notes, so definitely have this code by reference on the test. That way it can help you remember how to do these things. Circular queue. I'm just writing the word circular queue on top of this. This is 24. All right, so now let's take 23, rerun it, see if it works. Ah, you know what I should have done this also have a print function call here for the stack. All right, so you can see the stack thing works. We got this little dash at the end, but that's okay. And you can see that it prints in reverse compared to the Q one that we had before. Okay, so I will be uploading those as soon as class finishes. Any questions on any of these? Stacks, just the queues, the linked list stacks, linked list queues, arrays, all that stuff. Well, if there are no more questions, then congrats. We've finished the course material a week early, but that's expected because next week is study week. So yeah. I mean, you just have to think about all those edge cases, like plus, minus, and whatnot. You just have to be careful about it. I've implemented these things. What is this? I think this is like the 4th time that I teach 202, I think, maybe. And it's, you know, you'd think I have it by heart, but you can see that I still make a bunch of mistakes. It's just something, you know, you just do it and you test it and you fix it and you test it again until it works, and then you're good. And then you don't do it for a long time and you forget, but you can do it again if needed be. So the important thing about why you're learning this is not because you need to hard memorize how to code these things. It's because you start to learn how to take logic, how to take an algorithm, how to take instructions and convert them into actual code. That's what you want to practice and what you want to become good at. And what in Trio 2 you will definitely become good at, because that's what the real powerful thing is. I mean, in the real world, you're not going to code a stack or a queue. You're just going to call a library function that's going to do it for you. But you want to have that ability to quickly take someone's idea and convert it into actual code. That's what you want to practice. You only get that with practice. You want to do as much practice as possible, because there's no step 1, step 2, question profit like plan for how to become a good coder, other than just practicing converting someone's idea into practical code. So that's kind of what we've been doing, and all those a lot of the times people tell you to do something, but you have a different way of mindset than them, because you see, well, I can do this, but what about these edge cases? What about this specifics, right? It's like I'm doing data analytics right now for some data, and like there's like 50 different things I gotta think about before I can just run some code, because like they're all things that like someone wouldn't think about, but like you have to think about them when you're actually running the code, because they're like things that would crash if you don't think about them. So yeah, it's just a matter of basically understanding all of the tiny little edge things that you wouldn't think about otherwise, and just coding it in an optimal way too. So yes, get good. I mean, well, it's true. There's no. it's like sports, you know. You gotta do exercise to build up your stamina, right? You can't just like drink some. Well, I stand corrected. You could take like some sort of drug that like it may immediately makes you able to run like super fast, but you probably die afterwards. But you know, long terms you wouldn't be able to just do that. So you have to put in the work, right? That'd be cool if there was like a thing you would take and you just become like an amazing coder, like some Matrix thing. But that'd probably kill you in the process. So yeah. Okay. Well, I don't see any questions coming up. So yeah, that's all I have. Yes, Matrix. Game engines use different languages, right? Unity uses C sharp. Unity uses C sharp. Unreal Engine uses C++. The ID software engine, like the Call of Duty engine, and all the older ID engines use the C language. There's some engines for like Python and whatnot. There's also a Unity version of the engine that uses JavaScript. Yeah, well, as far as I know, it does. You can code in, you know, when you go and code in that, you just code in C++. Internally, there might be some things that are not C++, but at least the user interface is in C++. So, but if you want to do game development and you don't know anything, I would recommend you stick to Unity first because it's easier to learn. Even if you have to learn C Sharp, which is not that hard, it's very similar to C++ and Java. So I would go that route. C++, practice. If you want to go ahead, you can look at some of the videos and see what the topics are. Like you can learn like the ABL tree algorithm. You can learn your sorting algorithms, quicksort and merge sort. But I mean, all that stuff will be taught to you anyways. So it's just a matter of not like, in this case, it's winter break. So it's only a month. This is a bigger issue when it's summer break. That would say like, hey, practice coding because people tend to forget pretty quickly if you don't code. Like I tend to forget pretty quickly if I don't code. It's been a year since I coded C++, and the beginning of the semester I was like, oh, what is this? How do you do this? How do you do that? We all forget, so just practice. But winter break is short enough that won't be a problem. At least for me. For you, it might be different. Anyways, I know there aren't really any questions now, but next class is review day, so bring questions, because otherwise we have nothing to do. So I am going to just be here for any questions. I will try to do a pseudo review based on things that I think would be useful to review. Maybe older things, but I would rather you all come with questions of what you want me to go over. And if we really have nothing to do, I will fill the time by just doing Python. So, nah, I'd rather show you Python because I like Python. Python is good for you. Python is our friend. So, yes, I'd rather you. Because, I mean, some of you may only know C++. And you may be scared that other languages are like completely different, like some Spanish versus English kind of thing. It's not. I can show you Python in 1 hour, like pretty much at the level of 135 at least. Maybe part of 202 in 1 hour. So, and you'll be able to pick it up. So that's one thing we could do. But I'd rather do review if you actually have things. YOLO, I used a little bit of YOLO, but not a lot. YOLO is a image computer vision library to detect objects. It is for Python, so sure, maybe I could call a function. If I load a picture in and call YOLO on it, I could make it detect like a car in a picture or something. It's literally a matter of like it's like using a library. You just call a function that does detection and then you get something back. There's no difficulty with that. As long as you know how to call the function, which you can just look at the function prototype, see what the parameters are, what you get back, and that's it. We could try to code a game, but that is very short amount of time. We did the Tamagotchi thing. And that took us, like I said, like a full class, and it was like the most basic of games. There was no even interaction really. We just made it eat and do things. So that's a little short on time for that. All right, I'm gonna stop the video for the YouTubes.